You can take care of your car with the knowledge of its major parts. But your knowledge compared to the engineer that has the blueprint to your car, that knows every little thing about it, every nuts, screws, washers, and everything else, where do they go, what happens if they malfunction? Your knowledge compared to him is nothing. Now, car problems are painful, but they're not even comparable to heart problems. It is unsettling that we haven't been able to understand our hearts as well as we understand our cars. Recent developments in biomedical research, like Titan microscope, have helped us with opportunity to overcome this challenge. That microscope does look like a big closed box, but it does have buttons on it. As a proof, I brought the picture of Richard Henderson, 2018 Nobel Prize winner, pressing one on Titan. Titan microscope takes pictures, highly magnified pictures of our biological samples while they're frozen in ice. Thousands, sometimes hundreds of thousands of pictures are used to calculate a 3D structure. And if your 3D structure is good enough, you can locate every single atom in it. Every single carbon, every single oxygen, every single nitrogen, and even sulfur. Now, that can tell us a lot about our biological sample. Your heart is made out of proteins, and the proteins are made out of amino acids. A healthy heart is built out of correct amino acids in correct order. But some people, unfortunately, inherit some mistakes, some typos in the proteins of their heart. And their life is completely affected by something called cardiomyopathy, which is a heart disease. Now, it is not easy to work on human heart. Only a mad scientist will just jump into studying human heart while he's not ready for it. And that's how I'm going to address the giant insect in the room. Lithothrus indicus, 4 inches long, it swims, it eats fish, and it flies. But what's actually interesting about it is it has 2 large flight muscles that are 75% similar to human heart. Every amino acid you point at by 75% probability is the same as human heart. We're going to use that and extract it, and I'm pretending to put it in Titan microscope in this picture, and look at all the atoms. Now, this is a very large structure, very hard to interpret. But using our information from cardiomyopathy from medical research on humans and structure from Lithothrus, we can actually put cardiomyopathy, which affects 200,000 people per year in the United States, under the microscope. Thank you.